Chapter 8, evaluating expressions. Definition of a variable expression. A variable expression is a collection of numbers, letters for variables, operations, grouping symbols, any mathematical symbol except an equal sign and or an inequality sign. Pieces of an expression related by plus or minus are terms. Pieces of an expression related to a multiplication sign are factors. For instance, this is an expression, an expression, an expression. All of these are examples of expressions. A rational expression is a ratio, a fraction of two expressions. A rational expression like this fraction right here. The term is usually reserved for the ratio of two polynomials to be defined in another chapter. Chapter 5 or chapter 6, I think. Polynomials. So this is a rational expression. Now how do we evaluate rational expressions or expressions in general? To evaluate means to find the value of something. Evaluating 2a, which means 2 times a, if a is 5, means finding the value of twice the number in the a box, which is known in this example to be 5. Open a set of parentheses in place of the variable a, okay, like 2 times, open parentheses, drop in the variable and do your computation. Evaluate 2a plus 5 if a is negative 3. Open parentheses, drop in negative 3, crank out the number. Evaluate. You have a parenthesis here, drop in the numbers negative 2 and negative 3. You get a 12, you get a 24 for a sum of 36. Example 3. Evaluate x cubed minus y cubed over x minus 2y. Well, open your parentheses, drop in 4 for x, drop in 2 for y. Yeah, y was 2. You get 64 minus 8 over 0, which is undefined. Okay? The operation of dividing by 0 is undefined. Don't say 0 is undefined. Example 4. Open your parentheses for v, for pi, which is not really a variable, but, well, and x and y. And drop in the number. V was originally 3,140. Pi is approximated to be 3.14 in our examples. X is 10 and y is 3. So that also becomes apparently 942. Associate these two, you get 314. Don't draw arrows, okay? You can only distribute multiplication over addition or subtraction, not over another multiplication. So you get 942, and the difference is supposed to be 2,198. Example 5. You have a plus b quantity square minus a square minus b square. Now, don't make up your own rules. Don't make this a square plus b square, okay? Be careful. First, you do the innermost group. Remember PAMTAS. Please excuse my dear Aunt Sally. Your Aunt Sally is watching. Be careful. So you do the addition first. You're down to one number. And then you go to your next p, and you have a square. Now you have the square. So you plug in a, which is equal to 6, b, which is negative 6. So you get 6 plus negative 6, which is 0 quantity square, and you end up with negative 72. Example 6. You have a minus h over 2 capital B plus small b. Open your parentheses. A is 100. H is, what is H? H is 40. Capital B is 12, small b is 8. So you get 40, you get 20, 2 times 20, oh, we don't do 2 times 20. 40 divided by 2 is, 40 divided by 20 is 2, that 2. And yeah, 40 divided by 20 gives you 20 up here. Something is interesting here. You have 40 over 40, which is equal to 1, which is correct. So you have 40 over 2, which gives you a 2. That's where the 2 comes from, 40 divided by 2. And then you end up with 99. A rational expression. You open your parentheses, get ready to drop in the numbers. X is equal to 0.4, x is 0.4, y is 1.5 here and here, plus 1.99, over x, which is 0.4, plus 2 times y, which was 1.5. Crank this out, and you're supposed to get 5. See if you agree. Okay. You can stop this anywhere, and you can look at it. And then, oh, we are full of examples.